So last day we have seen Gibbs phenomenon. That means there was problem with using rectangular window due to abrupt truncation. We will have oscillations in the frequency response. That was the first Gibbs phenomenon, and to avoid that, you have to avoid abrupt truncation. So you have to go for smooth truncation using windows like triangular window, Hamming window, or Hanning window. And now let us see the equation for Hamming and Hanning window. As per your syllabus, you have to focus only on Hamming and Hanning window. So let's see the mathematical equation W of n for Hamming window and Hanning window. So both of them look similar. I will give you the mathematical equation first. I will give you a common equation for both with a parameter called alpha. So the equation can be written like this: alpha plus 1 minus alpha into cos 2 pi n by n minus 1. So for a window of length capital N can be sometimes 11, 15, something like that. So this is the window size, capital N is the window size. So this is the expression for W of n, your window. Provided this is the case, you can say that from minus n minus 1 by 2 to your n value varies from n minus 1 by 2. 0 otherwise. So this is what a window is. So when alpha is equal to 0.5, this window is referred as Hanning window, H-A-N-N-I-N-G, Hanning window. And when alpha is equal to say 0.54, your window is referred as Hamming window, H-A-M-M-I-N-G. So if you are asked to write the equation of Hanning window, if you want to use the equation for Hanning window, how the equation will be? It will be W of n equal to 0.5 plus 1 minus 0.5. So that will be 0.5 in both cases. So the equation comes like this: 0.5 plus 0.5 cos 2 pi n by capital N minus 1. And here the equation will be 0.54 plus 1 minus 0.54. So that will be 0.46, right? 0.46 cos 2 pi n by n minus 1. So these are the equations for Hamming window and Hanning window. Equation note we will do a problem directly. You can by heart this like this, or else you can by heart the common equation, and 0.5, both are 0.5 for Hanning window. And Hamming one is 0.54 and 0.46. Copy, we will do one problem. We will do the same problem that we have seen last class. We had designed a high pass filter and we have simulated in MATLAB. And you have seen the frequency response where you are having this oscillations, or where you have observed the Gibbs phenomenon. The same problem, Hanning and Hamming, which is let's see the response. Let's see what happens with the response. Okay, definitely oscillations has to disappear or decrease. Let's see what will happen. So you write the first question. Are you ready? Hello. Windowed equation clear. Okay. Yes, windowed equation under now nothing during truncation. Same like Fourier series method, except rectangular window. You have to use Hanning window or Hamming window, whichever is asked. Problem methodology. Okay, the change comes in the step of truncation. So first step is taking inverse Fourier series, right? Second step is truncation, and third step is shifting it right to make the signal causal. We will go through the same things. Only difference is at the step of truncation, that is in the second step, we will use a window. So write the first question. Design a high pass filter with cutoff frequency pi by 4. Design high pass filter, an ideal high pass filter with cutoff frequency pi by 4. For capital N equal to 11. Capital N equal to 11. For capital N equal to 11. Using can use this time. Using Hanning window, H-N-N-I-N-G, Hanning window. Using Hanning window.
Sir, question on the
Okay. You have to design an FIR high pass filter. You have to design an FIR high pass filter with cutoff frequency pi by 2. With cutoff frequency pi by 2. You can call omega C, right? With cutoff frequency pi by 2. Pi by 2 or pi by 4? I think it's pi by 4, right? Make it pi by 4. Pi by 4. നമ്മൾ കഴിഞ്ഞ ദിവസം സിമുലേറ്റ് ചെയ്ത പ്രോബ്ലം ആണ് കേട്ടോ. Hope you remember that. FIR filter, high pass filter with cutoff frequency pi by 4. For capital N equal to 11. For capital N is 11 using Hanning window. H-A-N-N-I-N-G. Using Hanning window. Using Hanning window. Just draw the response once. Decide response. You have omega. You have hd of e power j omega. Let me draw both sides, right? High pass filter pi by 4. Many people were having confusion in the last class to identify or distinguish the filters. It's pi by 4, so cutoff frequency is pi by 4. High pass, that means low frequency has to be attenuated. High frequency has to be passed. High frequency passing means gain should be 1. So pass all frequencies up to pi. Pi is the highest frequency. So this is the response. Similarly, we will have the left side also. Minus pi and minus pi by 4. Right. So what is the first step? First step. Hurry, fast. Someone please respond. Time play. First step in that, what you have to do, where you have to start with. Window inverse Fourier series. So you find hd of n. Okay. For the desired response, just take the inverse Fourier series. We would like to denote it as hd of n. So what is inverse Fourier series equation? 1 by 2 pi into integral minus pi to pi hd of e power j omega, right? Into e raised to j omega n d omega. So you can go for integration and you will get the answer. Just help me to write it using the shortcut. Denominator will be
pi n.
Pi into n, right? Numerator is sin just tell me. Rectangular box noka. Paranju.
Sin pi n minus sin pi by 4n.
Okay, sin pi n, this is first end minus second end. So sin pi by 4n. Or else you can use the direct integration. Minus pi to minus pi by 4, its value will be 1. Then pi by 4 to pi, its value will be 1. Okay, you can split it up. But at least shortcut is using or split it. Then you can write the answer directly, no issues. So this is your hd of n. So let's, what is the next thing? Second step, truncation, right? So to do truncation, what we do, usually in the last thing, we use the equation, say h dash of n, let it be the truncated sequence. So how will you find the truncated sequence? You have the hd of n with you, then you have to multiply it with w of n with your window. So this is the truncated sequence. So you have to perform this from minus 5 to 5 because capital N is 11. So you have to perform it from minus 5 to 5. So first thing is from minus 5 to 5, you have to find both these sequence. Just multiply the terms. That's it. So let's find hd of minus 5 to hd of 5. Similarly, w of minus 5 to w of 5. You find both the sequence separately. So let's start with hd of n. So you have hd of n equation with you. This is hd of n, right? So let's find hd of first term is say 0. hd of 0, you have to apply limit. We have done it already. Limit this thing So this will be 1 minus 1 by 4. So that will be 3 by 4. Hope you remember this equation. 0.75 will be the value. Then you can find HD of n. So you can find HD of 1, that will be equal to HD of minus 1. Then HD of 2, that will be equal to HD of minus 2. We have already done this in the last class. HD of 3, that is equal to HD of minus 3. HD of 4, that is equal to HD of minus 4. You just copy those values. Okay, HD of 5 equal to HD of minus 5. You will get all these values. Hope you remember this. Just copy that 0.225. This is minus 0.159. This is minus 0.075. Here it is 0, and here it is 0.045. So this is your HD of n value. Now you can find W of n. W of n means that that's your window. So for the window, you have to calculate all these things. W of 2 equal to W of minus 2. W of 3 is equal to W of minus 3. W of 4 is equal to W of minus 4. And W of 5 is equal to W of minus 5. And what's your window equation? W of n equal to okay. What is your window? Which window you have to use? Hanning window. Okay. Are you able to follow this? We're doing chain and all. Slow. This was the desired response. You take the inverse Fourier series, you got HD of n. This is having infinite terms. You truncate it to finite element, finite number. So to do that, we just simply actually this is truncation. The truncation then minus 5 to 5 like truncate. The problem is what will be the window you are using over here? Just direct copy. That means you are multiplying with a window value equal to 1. Rectangular window you see that this is exactly same because W of n value 1. But you are asked to use Hanning window. That means 0.5 plus 0.5 cos 2 pi n by n minus 1. N minus 1 is 10, right? So 2 by 10, so this is 5. So you have to use this equation to find W of 0, W of 1, all the window elements. Then you have to multiply this. Then only you can find your H dash of n truncated sequence. Pretty clear. If you have any doubts, you can ask. Clear? Ano?
Yes, sir. Yes, sir.
Okay, just find the values then. W of 0, 0.5 plus 0.5 cos 0. N is 0. N is 0 substitute here. Cos 0 is 1. So 0.5 plus 0.5, this will be 1. So first value is 1. Now W of 1 equal to minus 1. Substitute N equal to 1. You'll get cos pi by 5. Cos pi by 5. 0.5 into that plus 0.5. If you are using pi, do remember that calculator should be in radian mode. If it is in degree, you substitute it as 180. So cos pi by 5 into 0.5 plus 0.5. The answer will be 0.9045. Now, somebody just tell me what is the value of W of 2. W of 2 implies 0.5 plus 0.5 into cos pi into n will be 2. So 2 pi by 5, cos 2 pi by 5 into 0.5 plus 0.5. Calculator, just tell me the value. Someone please tell me. 0. ചെയ്തു നോക്കുന്നില്ലേ? ആരും ചെയ്യുന്നില്ലേ?
6545.
Okay, 655 എഴുതാം. Okay. Next one. ഒന്ന് രണ്ട് വാല്യൂ ഒന്ന് ട്രൈ ചെയ്യൂ. All of you do that. Just to practice out window value in the calculating. W of 3, substitute n equal to 3. So here you will have cos 3 pi by 5. Find the value of cos 3 pi by 5 into 0.5 plus 0.5. Tell me the answer.
0.345.
0.345. Now W of 4 next. That will be 0.0945. Okay. And the last value will be 0. So that's it. These are the corresponding decide or you got from the inverse Fourier series, and this is the window function in the span -5 to 5. Now truncation means you have to multiply this thing with this particular window. So when you multiply this, the result can be called as h dash. Okay, result in h dash in the. Now let me find h dash. So what is h dash of 0? Let me write over here. H dash of 0 is equal to hd of 0 into w of 0. Okay, hd of 0 into w of 0. So that will be 0.75 into 1 is equal to 0.75. Right? So this is the truncated result, truncated design. Now h dash of 1 will be equal to h dash of -1. That means you have to multiply hd of 1 into w of 1. hd of 1 into w of 1. So that will be equal to -0.225 into 0.9045. So you multiply that, you will get it as -0.204. -0.204. Clear or not? Next, h dash of 2 will be equal to h dash of -2. Direct multiply, you multiply these two values. 2 വരുന്നത്. That is -0.159 into 0.655. So that will be -0.104. Hope you are doing it. Calculator നിങ്ങൾ multiply ചെയ്ത് എഴുതുന്നുണ്ടെന്നാണ് എൻ്റെ വിശ്വാസം. നമ്മൾ അടുത്ത ചെയ്യുന്ന പ്രോബ്ലം നിങ്ങൾ അസൈൻമെന്റ് ആയിട്ട് എനിക്ക് ഒന്ന് അപ്ലോഡ് ചെയ്യണേ. I will just tell you. h dash of 3 equal to h dash of -3. Just multiply the corresponding numbers. 3 വരുന്ന values തമ്മിൽ multiply ചെയ്യുക. This into this -0.075 into 0.345. So that will be -0.026. Next values, but I multiply, but this will become 0. 0 into this will become 0. But this into 0, that will become 0. So remaining samples are 0. H dash of 4 equal to h dash of -4 equal to 0. Then h dash of 5 equal to h dash of -5 equal to 0. That's it. So you have completed second step. So is it my final answer?
No.
No. What is the problem with this particular design?
Non-causal.
It's non-causal. It's not realizable. That means you have to make it realizable. You have to right shift it by n-1/2. That means 5 units. So making it causal implies you have h of causal just add n-1/2. Just add 5 to this. H dash of 0 marita h of 5 of 0 plus 5. 1 plus 5. You have to go on like this. So h of 5 will be how much? 0.75. This will be the final design. Then h of 6 equal to h of 4. That will be -0.204. And h of 7 equal to h of 3. That will be -0.104. h of 8 equal to h of 2, that is minus 0.026. Then h of 9 equal to h of 1 equal to 0. Then h of 10 equal to h of 0, that will be equal to 0. So this is my complete design. So you can write your impulse response h of n equal to, you will start with h of 0. Okay, 0 comma h of 1 is 0, then minus 0.026, minus 0.104, then minus 0.204, then 0.75, then again reverse order. That means h of 6 comes here, minus 0.204, minus 0.104, minus 0.2026, 026, comma 0, comma 0. That will be your final answer. This is the final design. Just go through that once. We will try to see the simulation and we will stop. നാളെ കുറച്ചുകൂടെ ഫാസ്റ്റ് ആയിട്ട് നമുക്ക് രണ്ട് പ്രോബ്ലം വേണമെന്ന് ചെയ്ത് പ്രാക്ടീസ് ചെയ്യാം. ഓക്കെ, ഇതിൽ എന്തെങ്കിലും ക്ലാരിറ്റി ആർക്കെങ്കിലും വേണമെങ്കിലും നോക്കുക. പ്രോബ്ലം മൊത്തത്തിൽ ഒന്ന് നോക്കുക. വി ആർ ഗോയിങ് ടു വൈൻഡ് അപ്പ്. ദിസ് ഈസ് യുവർ ഫൈനൽ ഡിസൈൻഡ് ഫിൽറ്റർ. ഡൗട്ട്സ് ഉണ്ടോ? ഹലോ, ഹലോ, നിങ്ങൾക്ക് വിസിബിൾ ആണോ? സ്റ്റക്ക് ആയപ്പോൾ ഹലോ.
സർ വിസിബിൾ ആണ്.
ഓക്കെ ഓക്കെ, കംപ്ലീറ്റ് സ്ക്രീൻ മാറ്റ്ലാബ് സ്ക്രീൻ കാണാൻ പറ്റുന്നുണ്ടോ? മാറ്റ്ലാബ്.
Yes, sir.
Okay, so this was the frequency response that you have seen in the last class. Okay, ഞാൻ ഇതിന് കാണിക്കേണ്ട കാര്യമുണ്ടോ? ഒന്ന് നോക്കൂ, ഞാൻ ക്യാമറ ഒന്ന് ഡിസ്കണക്ട് ചെയ്യാൻ പോവാം. ഹോപ്പ് യു ഹാവ് കംപ്ലീറ്റഡ് ദിസ്. ഇതിൽ ആർക്കെങ്കിലും ഡൗട്ട് ഉണ്ടെങ്കിലും ചോദിക്കുക. ഞാൻ ആസ്ക് നൗ. ഓക്കെ, ഞാൻ ഈ ഡിസൈൻ ഒന്ന് റിയലൈസ് ചെയ്ത് നോക്കാൻ പോവാം. നിങ്ങൾക്ക് ഇത്രയും മതി കേട്ടോ. ജസ്റ്റ് യു ക്യാൻ സ്റ്റോപ്പ് വിത്ത് ദിസ്. റെസ്പോൺസ് നിങ്ങൾക്ക് മനസ്സിലാവാൻ വേണ്ടി ഞാനൊന്ന് കാണിക്കുകയാണ്. ഓക്കെ, so I have this is my first function. നമ്മൾ ആദ്യം ഡിസൈൻ ചെയ്ത ഫംഗ്ഷൻ ആണ് ഇത്. ഇത് ഓർമ്മയുണ്ടോ? ഇത് ഏത് ഫിൽറ്റർ ആണെന്ന്? This was using, you can cross check in your book. Okay, this was using rectangular window. Now let me implement my new design. Just tell me the new values. First element is 0. Okay, second element is 0. നിങ്ങളൊന്ന് ക്രോസ് ചെക്ക് ചെയ്തോണേ ടൈപ്പോളജിക്കൽ എറർ ഉണ്ടോ. മൈനസ് 0.026, right? Then 104, minus 104, right? Next, minus 0.204, 0.75. Okay, then here 204, here 104, then 0.026, nearest, let's cross check, 0 space 0. Is that okay?
Yes, sir.
Okay, so this design is using Hanning window. Okay, so you have designed it using Hanning window, H-A-N-N-I-N-G. Now let me see the response. Just എനിക്ക് response ഒന്ന് കണ്ടു നോക്കണം. So I will have two figure windows. First one is rectangular window output. Second one is I will have the output of Hanning window, right? So this is the first figure. This is second figure. See, first figure, hope you can see both. In the compare. First one, what was the issue? You had ripple. See, you have a large ripple over here and some smaller ripples also over here. Here you can see that we have eliminated the ripples or the oscillations and it's maximally flat. So here you have the Gibbs phenomenon and the solution was using a smooth truncating window like Hanning window that we have done for this particular problem. Maximize EM, you can just cross check. This is perfectly flat. You have no oscillation at all. Clear? Hello?
Yes, sir.
Okay, so this is how you can eliminate Gibbs phenomenon. Now, someone please explain me what is Gibbs phenomenon. We'll wind up. We conclude.